Okay, welcome to the next lecture of SEG 2100. Today what we're going to do is we're going to work on the board. We're going to be solving a UML class diagram drawing problem on the board. The problem is one of the problems that you'll find in the textbook. In fact, it is part A of question E 518, 19, and 20. Okay? So 518 is saying find the classes, 519 saying going a bit further, 520 is saying going a bit further still. Okay? So there's a whole series of questions like that, some of which you're doing in the assignments. And this question, part A, is the bank accounts management system. There is an answer to part A online. Go to the website, find the answers. You'll find this answer online, so you don't have to write in detail down what I'm drawing here. Although you might want to jot down the procedure that I use, okay? But the answer is online, and I sincerely suggest that you go and study the answers that are online for a lot of questions in the textbook, because that'll help you to understand difficulties that you might have trouble with. You know, you can try doing the problems yourself, and then if you have some kind of difficulty, you can go and see what the answer is, and that'll help you to learn what the problems are. Okay? Alright, so we're going to be dealing with the bank accounts management system. The actual problem description of this system is located in the back of the book, okay? It is, if you go into the back of the book, you'll find there's an appendix there, and in that appendix, okay, page 448, you'll see the text which I have on the board up here, okay? It says bank account management system, and it's got some general text describing this system in some detail. Alright? What we're going to be doing now is we're going to be taking this text, and I'm going to ask you just to, I'm going to read through bits of this text, and I'm going to ask you to think, as I'm reading through it, how we're going to turn this into a class diagram. I'm going to read through the text, and then we're going to start thinking about, first of all, what classes are the kinds of data that this system is representing. What kind of classes are we going to have to put into a system to represent and manage the data that is being talked about in this little statement of requirements. Now, the statement of requirements is basically one large paragraph. That is actually not good. We would like to actually start off with a more detailed set of requirements that had broken down into individual sections with bullet points and stuff like that. But quite often you do get clients describing things in a rather amorphous state, and so we're going to take this step of modeling a system where all we have is one very large paragraph to work with. Okay? So as I go through this, think about the classes, and we're going to do this interactively. I'm going to ask you questions, and I'm going to put down on the board whatever you tell me initially, and then we're going to gradually work through and say what is good, what is bad about what you've suggested. Okay, so the problem says bank account management system, and it says the system provides basic services to manage bank accounts at a certain bank. Okay, it's got many branches, each having an address and a branch number. It says a client opens an account at the branch, and each account is uniquely identified by an account number, has a balance and a credit or overdraft limit. Okay, then the next sentence goes on to say there are many types of accounts, including mortgage account, checking account, credit card account with different properties. Okay, it's possible to have a joint account. Each type of account has an interest rate, monthly fee, specific set of privileges, okay, which are listed. It says the bank is divided into various divisions and subdivisions, some of which are listed. And it says the branches are considered subdivisions of a certain division. And finally, each division has a manager, set of employees, and each customer is assigned an employee as a personal banker. Okay, so there's quite a lot of stuff in there. What we want to do is we want to start thinking about nouns. Because basically what happens is that the classes are things that represent things in the world, and things in the world are represented in English as nouns. Okay, so we're going to be looking for nouns. Not all nouns are going to end up being classes, but a good percentage of them will be. Okay, so let's just go to the board. I'm going to work over here. Later on, I'm going to use the middle part of the board, but for now, I'm going to work over in this section and the far section. And what we're going to do is we're going to start listing what you think, out of this text that you see there, are possible classes that we should have in this system. Okay. So any hands up who wants to say suggest a class? Okay, yeah. Branch. Okay. I'm just going to put down whatever you say. Somebody else's hand up in the back. Employee. Okay. Somebody else. Yep. Division. Okay. Interesting. We're starting from the bottom here. Anything else? Yes? Oh, sorry. The two together there. In the far back?
Oh, account.
Account. Okay. Somebody else? Customer. Any other classes? Somebody over here? In the back?
Bank.
Bank. Yep. Manager. Okay, any, yep.
Joint account.
Joint account. Notice that I am writing them down as classes with capital letters and words like that. With, you know, single word with a capital S, standard class naming convention. That doesn't mean they're going to be classes all. Okay? Any other suggested classes in here? We'll skim down the text, starting at the beginning, and think, have I got everything that's probably likely to be some data? One of the strategies, by the way, to use is to go and underline things, or to mark them out, circle them in your text. So, for example, I could do that by just going in and reading through, and if you want to circle all nouns, I would circle the word system. But notice nobody suggested system, and that's a good idea. Nobody suggested system because indeed system is not something which we're going to actually be implementing, because we're not storing data about the system, so that's okay. Services is also a noun. Okay, we could have put that down on the list. But one of the things I'm going to suggest is that sometimes words like services are rather vague, and unless we had something more specific, we might not want to put it down. But it would have been okay if it was on our initial list. We might decide later on that it wouldn't be reasonable. We've got account, okay, we've got bank. OO Bank is a proper name, and generally speaking, proper names represent instances, not classes, even though it's a noun. We've got branch. What about address? Does anybody think that should be a class? Okay, we talked about that before, right? We suggested that generally speaking, it could be. You know, it depends on whether we want to manage more than one address or not, right? There's a number of possibilities there. I put down what you suggested, but what I'm saying now is that you could go through and underline these, or I could bold them, for example, if I wanted to. If I'm editing my text, you know, client. We have client there. We have customer. Okay. Well, I'm going to put client down here because we might decide that it's the same thing, or we might just analyze and see that it's something different. Anybody else think of any other classes in this list that we might want to have? Yeah.
Mortgage account, checking account, credit card account.
Okay, what I'm going to do there is I immediately know that I already have an account. So I'm going to put mortgage account, checking account, and what's the other one? Credit card account. Okay, so I mean that's looking like a generalization, right? You know, I'm not putting it directly as a generalization right away, but it certainly looks promising as if it might be. I have joint account already down here, so I can put a little tie like that to say, well, when I'm thinking about this one, think about that one too. Any other possible classes? Last call for the first round. Okay, yes.
Just in looking at the way it's structured, we may want an address as a class just because both customer and employer are both going to have separate addresses, and the mortgage account is going to need property as collateral as well, so if we refer to address information also.
Okay, so she's suggesting that address probably might very well, in this case, deserve to be separate because of the fact that we might have different addresses on an account, possibly, and also we might possibly have the address of the mortgage property, and that makes a lot of sense to do that. Right. Okay. Let us let's leave it at that point, okay? We've created an initial list of classes, and we might think that that's good. What we're going to do now is we're going to start thinking about the associations and attributes. Okay, that's the next step in the process. Okay, the next step in the process is to say, okay, we've got an initial set of classes. Let's actually start drawing the class diagram bit by bit, thinking about individual associations and individual classes that, individual associations, individual attributes that belong in those classes. Okay, and the strategy we're going to use is we're going to think about starting at the central, the most important, the key class in this system. Okay. So what I want, next thing is, first you have a question here.
I wanted to ask about a credit card, because we have many cards for on one account.
Excellent.
And
definitely, yes, absolutely, yeah, that makes a lot of sense. Yeah, he said we have many cards on one account, and therefore credit card deserves to be another separate thing as well. That makes a lot of sense, right? Okay. Now, what do you think is the central class or the central couple of classes in what we've written down here? Okay, what do you think? Hands up, where we should start the process of modeling from? And yeah, bank. So one person says bank. Any other suggestions as to what might be the central class? Yeah.
We can create a class, like a superclass for employee and customer, like person.
Okay, let's get to that later on. I want you to answer my question about what you think is the central class. Yeah. Account. Okay, so we have one suggestion that account is the central class. Another suggestion is that bank is the central class. Any other thoughts about what might be the central class or central couple of classes? Okay. That are linked. Customer is another possibility. All right. So. The general concept is that you find the class that seems to have the most to do with the problem. You know, it's the class which has the most, it has associations leading out from it, and which everything is basically about. Now this is about a bank, but there's not a hell of a lot said about the bank here. The bank is going to be an individual, probably just one instance, and in situations where we have just one instance, we might not actually even have to have a bank class. There's just one instance, the whole system represents the bank. So when we, generally speaking, don't start with that kind of class. We start with a class that's going to have lots of instances and lots of links to other instances as well. Okay, and so to me, account seems like a good starting place. Customer possibly also, but account, after all, it does say big accounts management system. So clearly, account is pretty important. Question.
I was going to say branch.
Okay, you're going to say branch. Well, I just suggested that account is the best thing, because really it's all about accounts. Okay? So I'm going to, I hope most of you have got your books there. If you don't, share with somebody. I'm going to flip this screen off because we don't have enough actual space in this classroom. I will flip it on again once or twice so that we can take a look at it again. We're going to put this thing up so we've got more space to work with here. And we're going to start. We're going to put down on the board here this class account. Okay. And now what I want is you to tell me what we know from the problem about accounts. What do we know about accounts? Associations or attributes? Somebody want to tell me what we know about the accounts in general? We know nothing. Ah, somebody has an idea there. Yes.
Each account is identified uniquely by an account.
Okay, we have an account number. Okay, account number. Anything else do we know about accounts? Yeah.
There's a client who has the account.
There's a client that has the account. Does that go as an attribute or an association? Yeah, okay. So I'm going to put that in as an association. Remember, the rule of thumb is that if it's simple data that is going to be uniquely tied to the instances of the class, okay, like strings and numbers and maybe other simple data types like dates and times, it can be put in as an attribute. Okay, it belongs as integrally part of the instance. Okay, there's only one of them. It's always got to be exactly one account number per account, etc., etc. Then it belongs as an attribute. On the other hand, if it's a separate entity where there can be many different kinds of relationships in our model that we're creating, and it's going to have some complex data inside it, then it's definitely going to be a class, in which case the relationship to account is going to be association. Okay? As soon as we put an association, the next thing to say is, what is the multiplicity? Always put the multiplicity in as soon as you put an association down. So, what is the association? What goes on the account end first? Hands up. Hands up who wants to answer that question. I heard somebody. Yeah? Many? Okay. So we're saying a client has many accounts. Okay? And the other way, an account has how many clients? Yeah? Somebody says one. Somebody else says one or two. Somebody else says
one or two or more. If it is account of an organization or a business firm, it might be.
Okay, so we have a number of suggested possibilities here.
How about
okay. Sorry?
0.
0. Okay, well, so that means that somebody's suggesting that it should just be star, because we've got a lower bound of 0 that's suggested and an upper bound of some arbitrary number. So let's analyze this thing a little bit. Does it make, first of all, let's take lower bound, because lower bounds are often easier to deal with. Does it ever make any sense for an account to have 0 clients? How many people think we should allow 0 there? Okay, we want to allow 0 in cases where, for example, when you first set something up, the 0 might make sense for a short period of time, for a few minutes, a few hours, or something like that. Or when, you know, there could at some point during the lifespan be 0. And it seems to me that having an account with no clients seems a bit odd. I can imagine situations when sort of I change, you know, an account from one person to another because it gets, you know, gets moved on or something like that. But generally speaking, that kind of temporary case where it would be 0, we don't consider. We consider all times when the data is stored over any period of time. What is the lower bound? So I would suggest that a lower bound definitely here ought to be 1 in this particular case. The question is what is the upper bound then? Somebody suggests it should be 2. I think that definitely it has to be at least 2. The question is could it be more than, because it says joint account. What about more than 2? Does it make sense to have, say, joint accounts with 3, 4, 5 people? Now, somebody suggested corporations, you know, or clubs or organizations having multiple people as the clients involved. I don't think that that's the way that's going to work. However, what we're going to do is we're going to go to the clients and find out. We ask our clients, and the clients come back and tell us, no, the clients are the signing officers of the account. Okay, so we have to go and get the domain information. We have to get the requirements. The signing, how many people can sign on the checks? Those are the people that have to go here because they don't really care how many people are in your organization, you know, and they don't want to have to keep track of those. I mean, they're not a membership list, okay. So they just want to keep track of a small number of signing officers. Yeah.
Would it not just be the name of the corporation as a client?
Okay, if it was a corporation, that would be fine. But again, we ask the clients, and the clients come back to us, and they say, well, in fact, yeah, 1 corporation, but if it's a partnership, then it would be 2 people. Or if it's a husband and wife, that's 2 people. So they like an upper bound of 2. Larger than 2, they want you know, they don't want more than 2, but 2 is their upper bound. Okay, now, so you say, how am I going to do this on the test? You know, how am I going to do this when I don't have the domain knowledge? Well, the answer is that if you were in the real world, you would go and find the domain knowledge. If you are doing a test, doing an exam, then state an assumption. Okay, so if you stated a reasonable assumption and said that, you know, I've analyzed this, I see several possibilities, and I can see a case for 2, I can see a case for many. And the case for many is a case of, you know, a corporation or something, or whatever. And I can see that you lack domain knowledge, I will accept it as a right answer, okay? But you've got to state the alternatives if you're unclear on which alternative to pick, all right? Don't just randomly pick. So we're going to say this is a start of 1 to 2 relationship. This is a very strong bounds. It's one of those cases where, in fact, it is legitimate to have, I think, strong bounds. What else do we know about accounts? We've got the account number. What else do we know about them?
Type, saving, checking.
Type. Okay, so somebody suggests type. Okay. I'm putting them down for now. We're going to make changes later on, perhaps. So, in the back, yeah?
Would you not have just extensions of account, like mortgage account, checking account?
Subclasses.
Yeah.
Okay, so this fellow suggests we have a type attribute, and this person suggests that we have subclasses of account. Over here, we can definitely see we've got mortgage account, checking account, credit card account as potential subclasses, and perhaps joint account. So the question then becomes, are we going to, in fact, do it this way with a type attribute, or are we going to have subclasses? And how can we tell? We can tell if there's going to be differences in the data that we're going to need to store associated with each of the subclasses, so different attributes, different associations, or different operations. More than one, typically, operation that is done in a different way so that we take advantage of polymorphism. If there's just one operation that's different, I would probably tend not to do it. Okay? So in this case, can we think, are there any significant differences between the bank account, the mortgage account, the checking account, the credit card accounts? Any differences that would lead us to want to have subclasses? Somebody who hasn't spoken yet, maybe. No? Okay, in the back then?
Interest rates would be calculated differently for each.
Perhaps interest rates would be calculated differently. Can we think of any other differences? Yeah.
Mortgage account has a property.
Mortgage account has a property associated with it. So that we definitely need to have a subclass there. Any other differences?
Some are saving accounts where you put your own money, and others are borrowing accounts.
Okay. He says that some are savings accounts, some are borrowing accounts, and therefore there's a difference in structure somehow, typically to do with various factors such as the interest rate calculation that were mentioned. So it sounds as though there's going to be different algorithms involved for sure. Any other differences? Yeah?
Credit card account expires.
Credit card account certainly has something to do with expiring in it. We'll figure out exactly how that works later on, but there's definitely that notion there. All right, so we've definitely got at least two differences, and that's enough. We're going to have subclasses. But a few more comments.
Yeah, we have different fees and stuff for all the accounts. It's like different range of fees.
Different ranges of fees.
Rates the bank charge.
Rates the bank charges, okay. Okay, now, one of the things to remember is that if all the accounts can have different fee ranges, it might end up being that rather than creating subclasses where each subclass has attribute fee range, in fact that can go in a superclass and then we can have individual subclasses each of which. There's other ways of dealing with that. We'll get to that issue later on. But certainly we've identified the mortgage and the credit card are clear. They're going to be associations. That's going to tell us that rather than using a type attribute here, okay, we're going to make subclasses. I'm going to leave a bit of extra space for extra attributes here, and I'm going to create some subclasses in here. Okay, so we have a generalization arrow, and then I'm going to have 3 subclasses, and I'm going to have checking account. You can spell it in the American way or the British way. Chosen the British way here. We've got mortgage account. Okay. And we've got credit card account. Okay, so now we've added a bit more to our diagram. It's getting a little bit more complex. There's still some stuff to fill in the account. I think what we'll do is we'll try and finish off these attributes first. Are there any other attributes that we should put in account before we get down to the subclasses? Yeah?
What about on the accounts you would say whether it is a joint account or not? Because it could be, the joint account could be either checking, mortgage, or credit card.
Okay, so her question was, how about we say whether it's a joint account or not? Well, the answer to that is we've already done that. This here is saying if it's 2 clients, it's a joint account. If there's 1 client, it's not a joint account. Okay, so the number of clients gives us that information. We can just say how many clients. If more than 1, it's joint. Okay, so that one's dealt with. Any other issues? Yeah.
Open date and closing date.
Okay, we can have the opened date of the account. Okay, close date. Now that isn't explicitly written in the text. If you look at the text, you'll see that it doesn't actually mention, I think, either of these 2 things. That might mean that it's beyond the scope of the requirements. On the other hand, it might also simply mean that, well, they didn't write it down. Okay, so we have to go and ask our clients and iterate with our clients, and we'll add things and delete things later on. But I'm putting it down now because it makes sense. I would flag it and just ask my clients about whether they really want those things in there. Okay? Yeah? Interest rate. Okay, you can put that in there. I probably should spell it out, but just save time on the board. Yeah? Monthly fee. Okay. Anything else? Balance? I was waiting for that. Okay. The balance is usually the first thing people mention, you know, and it's usually the most important thing about the account after account number. Okay. Any other things that are there? I'm just going to double check that I've got. There's one more critical piece of information that we don't have yet that I would expect to have. Yes?
Each account has a
Credit
credit or overdraft.
or overdraft? You seen the answer? You pronounce it exactly in the same way that I would have done. Yeah, I'm going to call it credit or overdraft limit. Okay, right. Yeah. Of course, she's just reading the text actually as written there, which is exactly what you're supposed to do. She's reading the problem statement, and it does say each account has a credit or overdraft limit. So you're supposed to read it. That's the whole idea. Okay. So those are the key important things. Notice that we can treat this as one thing. This is the largest negative value that can be in any account. Okay, so mortgage accounts are normally going to be negative. Well, you're borrowing money implicitly. So is a credit card account. But you can make a credit card account positive. Okay, you can go to your credit card and you can deposit a whole bunch of money into it, which basically gives you more spending room. You can do that. You can overdraw a checking account and make that negative. So all these accounts, except perhaps the mortgage account, can be positive. Mortgage account can be, and they all can be negative. Okay. You have to have permission to make a checking account negative, but it can be done. So we're going to just use one value, which is the lowest negative value. Of course, the highest positive value, there might also be limits on that in some. No, I don't see why actually. In the largest positive value, you know, you deposit money. You can deposit $1 trillion if you were Bill Gates into the checking account. That wouldn't mind. The mortgage account would be kind of silly. You'd never make that positive. Credit card account, yeah, would be no point making it very large, but you could. Okay, so there's no limit on that. So we just need a value which says what is the largest borrowed amount that we can have. Okay, so that's a set of attributes. We might later on go and fiddle with these a little bit, but that'll do for now. Let's get down to our subclasses. We put some subclasses in. What is special about these? What is special about checking account? Is there anything special in the problem statement that we want to add to checking account? At this point. We don't have to. There doesn't have to be. Okay, we'll leave that then. What about mortgage account? Okay. The lady over here on the right has been mentioning this a number of times. So how should we deal with that? Property. Okay, we have the property, right? So how are we going to represent the property? Is that an attribute or association? Attribute or association? How many people think it should be an attribute? Hands up. How many people think it should be an association? Hands up. Okay. There's a slight vote in favor of association, and a lot of people on the fence. The answer is that it probably could be either, depending on the nature of the problem. If we make it an attribute, okay, we're just going to call it property. It basically means there's a description, presumably with an address and a few other things in there, that is just written in as text describing the property. If it's going to be an association, that means that opens up the possibility that we could actually have more than one mortgage on the same property. Okay, that would be a possibility because in fact banks can have first and second mortgages. That's one possibility. It also just means that it's in some sense that we can manage the things, the property information and the mortgage information separately. If we were to make it an association to property, okay, what would be the multiplicity? Hands up. Any ideas?
One property, more than one mortgage.
One property, more than one mortgage. Okay, so one and possibly one ... maybe, or maybe not. Maybe we have a property in there, the mortgage is being paid off. We still have a record of it. Could be probably lower bound 0. Upper bound is presumably going to be pretty low. You're not going to have a large number of mortgages on a given property, but we don't want to maybe put a specification on there right now. But maybe the bank will give us some high value at some point. Okay, I'm going to leave it as an attribute for now. We don't have any information about the property. Doesn't say, in the problem statement, it doesn't have any information. We can leave that and discuss that with our client later on. Okay. We could also, by the way, later on we have an address of the bank branch, and we could actually have a separate class for that. In fact, we have over there. What about credit card? How are we going to deal with credit cards? What information do we have about credit card? In fact, credit card accounts, it says here. What do we know about them? Yeah.
Expiry date?
Okay. Does a credit card account have an expiry date? Is that what has an expiry date? How many people think a credit card account has an expiry date? What does it actually say in the problem? In the problem, we go look at the problem. It says, checking account and a credit card account which has an expiry date and can have secondary cards attached to it. So it does say a credit card account has an expiry date. Right. So we can put that expiry date in there. But then we have to think. Maybe the clients don't always get their problem statements right. Because if you go and actually think about it, you take out a credit card out of a bank, and that credit card on it has an expiry date on it, but they'll send you a new one. And, they're not going to close your account the day it expires. They'll send you a new one with a new expiry date on it at some point, right? So the card has an expiry date on it. So is it the account or is it the card? That is something we'd have to go and ask the clients about to clarify that. If you put down expiry date right here, I wouldn't mark it wrong, because it could be, in fact, that that's the way it is, and that the expiry date keeps getting moved up, and all the cards have the same expiry date. That could be the way it is. That's something we'd have to check with our clients. We don't want to be brazenly just write down whatever we feel like. We've always got to check these things. If there's any doubts, we've got to check them. Okay? But that could be the right answer. It also could be on the card. Yeah?
On an exam, obviously we can't ask you whether it's recognized, so...
You state an assumption.
What if we put, like, for example, the closing date of credit cards and then the expiring of the credit card? Would that work?
If you put expiry on the credit card, yeah, that would be fine too.
Closing date on the credit card account.
Closing date, well, okay. But that's an interesting point. We have closed date already inherited to all these things. That's the date that the account was finally shut down, which is maybe different from the expiry date, because you can close your credit card account any date. But closing date, instead of expiry date, is a synonymous. I would accept that. I mean, the names you choose are not critical as long as they convey the same information. Okay? And as long as they are precise enough that aren't vague. We talked about the different meanings of bus earlier on. Okay, so expiry date could go there. What about the credit cards themselves? Any thoughts about that? Yeah. Okay. Is a credit card number the same thing as the bank account number? Or the account number? Okay. So how are we going to deal with this? How are we going to deal with the credit cards then? Yeah. Visa, MasterCard, American Express, etc., etc., etc. Type, credit card type is your suggestion. Okay. Well, maybe in fact this bank does allow for different. And some banks do. Okay, so we can say, I'm going to call it brand, okay? Because I don't like the word type just on its own unless it's vague. Where brand has a stronger meaning. Visa is a brand, MasterCard is a brand, American Express is a brand, okay? So that's an interesting thought. I didn't actually have that in the answer. So that's a thing I hadn't thought of. I was thinking of a bank that had only one kind of credit card. Yeah?
So these two, we could put one-to-many relationship with credit card that has an expiry date and the brand.
We could have, he's saying, a one-to-many relationship between a credit card account and credit card. Okay, does that make sense to people? Okay, now he's saying that it can have in it attributes such as expiry date and brand. I'm going to suggest that the brand doesn't belong here, though, because if I have an account, it's going to be a Visa account, or it's which has several cards for different members of my family, or it's going to be a some other account. If I have a bank that has multiple brands, like and I have a master, the brand I think would go here. I would make that judgment. We ask our customers. However, again, if you state an assumption on the exam, I'm not going to be fussy about that. So I think that goes there. Expiry date, you're right, could go here or could go there, depending on the bank's requirements. Okay. Other hands up there. Yep.
I think the brand would be a generalization. You'd have Visa credit card account.
Oh, okay. Well, he's suggesting that we put a generalization here. So subclass of account is credit card, and then underneath that we're going to have some subclasses of credit card account. Okay. As soon as you think subclasses, you've got to think, what's going to be the difference among them? Are we going to have different associations, different attributes, different operations? What do you think?
Well, I think maybe one of them you get money back for carrying a balance, or you get savings at different stores, or your interest calculated differently.
Okay, so he's suggesting that we have all kinds of features on cards, like savings at stores and money back points and stuff like that, okay? Now, what you're suggesting, then, is that basically every time we come up with a new kind of set of features, we're going to have to create a new class and subclass it and add the extra features. Okay? That's something we have to think very carefully about. In modern banking, the banks are coming up with new types of credit cards, about one per day. And they're going to be programming really fast to do that. However, having said that, it might be that those features are so complex that you actually do have to do programming. So you're right, there might be subclasses down here. But it isn't in the problem statement, so we're going to leave it off. But you're right, it's a valid possibility that there might be so much complexity in subclasses that we might do that. Okay? What else do we know about credit cards and credit card accounts? Yeah?
I just have a question. What bank offers more than one credit card?
A lot of American banks do. Most of the American banks do. CIBC does now. They have American Express and Visa in Canada. So it is done. It's just the Canadian rules have generally limited it to one brand per bank, but that rule is gone now. Yeah.
Just an idea. All credit cards generally are divided by their card numbers. For example, all MasterCards start with 5, and all Visas start with 4. And American Express is 3. But so the credit card account number would likely be the account number, the exact same number that's on the front of the credit card. So you wouldn't really need a credit card class on its own, that credit card account. Just its number alone would indicate the...
Okay, what she's saying is that in actual fact we might not need the type or the brand, because we can tell the brand from the card number, because each brand has a separate series of numbers. Okay, that might be true. However, I would also suggest to you that kind of thing might end up changing. If Visa runs out of its series of numbers, they might get a new series of numbers. And so it might be simpler just to keep the brand in there, even though it might be slightly redundant, as a double check or as extra information. But you're right, sometimes is information encoded in a number. However, talking about account numbers, okay, we have account number. That is the number on the card. If you have multiple cards, do they all have the same number on them? On multiple cards on the same credit card account. One for you, one for your wife, one for your kids. Do they not? Okay, that's an interesting question. They do. It's certainly in the cards that I've had, the Visa cards that I've had. But it's actually a question that you would do domain analysis to find out if that is generally true. But let's make the assumption on this bank that is the case. So the card number is just the account number. But what is unique about each card? Right now we've got this thing here with no attributes. What is unique about this card? The name. Definitely there's going to be a different name on each account. On each card. Okay? Alright. So there's a number of possible variations there, but we've honed in on that one. Let's go back over to this side of the board here and take a look, take stock of where we are. What have we dealt with and what have not dealt with? We've dealt with accounts. We've dealt with the 3 subclasses of account. We've dealt with, that's pretty much it. We've dealt with client. Okay, we've got client in there, which is this thing called customer/client. Again, you could use either word, customer or client. They tend to be synonymous in most contexts. All right, what else do we know? We've got some other classes over there. What else do we want to now work on? What attaches to these things?
Credit history of the person.
Okay, he's talking about credit history. It's outside the problem scope. Any other things? Yeah.
Okay, you know how you made a credit card class? Why don't we make a card class? Because the checking account also has a card, and there's no real difference between the cards.
Ah, okay. So he's suggesting that all accounts can have cards associated with them.
Well, at least
Okay.
checking, I don't know.
Okay, that's a possibility because we can have a card associated with a checking account. In which case, if we did that, this association would move over to here. I'm going to argue that we could do that, but we're going to leave that out. That isn't in the problem statement right now, but that is a possibility. One of the things I would say is that generally speaking, these cards that you use in ATM, debit cards, and so on, they have multiple accounts on them. That's one thing. Okay, and they can work with checking accounts and credit card accounts, but the actual credit card is a distinct kind of entity that has some different properties about it. So that's what requires further analysis, and let's leave that out. It isn't in the problem statement. But you're right. That's a decent observation that we do have other kinds of cards here to play with. Let's leave what we've done and think about new stuff, because we don't have a lot of time to work on this. What else can we add to this diagram to deal with other parts of this? Let's talk about the bank branch. Where does that go? Bank branch. What do we know about the bank branch? In the back. He says that the bank branch is a superclass of account. So an account is a branch. Right. The account is not a branch, for sure. That's definitely not right. Okay. A branch has accounts. All right? So we're going to put branch, and we're going to say that it has a set of accounts. Multiplicity, one to many. Account belongs to one branch. Anybody object to that? Yeah, you don't like that?
Branch has client.
Okay, branches have clients as well. Okay, fine. So we can do that. We can say that branches have clients. Okay, a branch can have many clients. A client can belong to one branch or many branches, in fact. So many-to-many relationship. It's interesting. Okay. What else do we know about... I see many-to-many. As soon as I see many-to-many, I think, interesting. Is that an association class? Is that an association class? Is that in a class where we can say that there's a relationship where there's something about in the relationship between branch and client that would warrant having its own class? Anybody think there is? You think there is?
Yeah, the account is the association class.
No, I'm talking about the association class between branch and client. Many-to-many. So is there a class that goes here? Oh, yeah?
Wouldn't your association class indirectly be the account class? Because you can't have a client of the branch without having the account. If he doesn't have an account, he's not a client.
That's not the concept of association class, though. The concept of association class is on a many-to-many relationship. Okay? That's what we're talking about. The relationship between... We see that this is many-to-many. Okay? Because a client can definitely have banking more than one branch, and a branch can definitely have more than one client. Is there something that we could put there? I'm not saying there is. I'm just saying every time you come up with many-to-many, think, is this an association class? Could be, maybe not. Okay? We'll analyze that further later on. Nobody's come up with ideas right away. Yeah? Employee class. Okay. Let's put down employee. Okay. Now he's suggesting that this be ... like that. What do we know about employees? What does it say about employees in the problem statement? There's two main things it says about employees. Okay. Take a look at the statement. Let me temporarily flip this thing back just so that you can have a glance at this statement for just a second here. Okay. What does it say about employees? This is stuff at the bottom here. It says that among the things, a customer is assigned a particular employee as his or her personal banker. Okay, and above that it says each division has a manager and a set of other employees. Those are the two statements about employees. Okay? So what do we know? How are we going to tie the employees then into this diagram? Yeah?
Well, an employee has many clients, and then you can go from branch to employee and not have
An employee has many clients. How are we going to label this association? How are we going to label this association? What does it say? What does the actual text of that statement say? I can read it out again if you don't have it in front of you. It says, each customer is assigned a particular employee as his or her personal banker. So this personal banker thing is a role name. Okay? Personal banker is a role name. Employee has many, possibly many clients. And oh, is that right? Is that right? Is that right? No, other end, right? That's why you got to read these associations. You come to a piece of information, you write it down. If you don't read the association every time you change it, you end up making mistakes. Personal banker is here on the employee end. Okay, so a client has an employee as a personal banker. Personal banker can be the personal banker of several clients. All right, so that's a reasonable thing to do. And while we're on the topic of employees, what is the other information that we know? Yeah?
A branch has employees.
A branch has employees. Fine. Okay. A branch has many employees, an employee works at one branch is probably a reasonable thing. We've got a lot of associations here now. You know, we've got branches have clients, branches have employees, you know, it just seems that we've got some kind of an interesting relationship. What I'm going to suggest, perhaps, is that we don't need this association directly between branch and client. Because in some sense, a branch has got accounts, and an account belongs to a client. Okay? Earlier on, somebody was saying account should be the association class. Yeah, I wasn't thinking straight when I said. In fact, it does look like that, doesn't it? Many to one, many to one. Yeah. So that, in some sense, that's what that is. I was thinking that you were telling me that it was the client that was the association class, but it's the account. Yeah. My apologies for that. So that goes away. Still at 1, 2. Okay, so that we've now got this notion that branches have employees, clients have personal bankers.
You can say the other way. Each branch has some clients, and each client has some accounts.
Each branch has some clients, and each client, right?
Client has multiple accounts.
Yeah, client has multiple accounts. Basically, what we've got, we could draw this sort of like this. Okay. Star, star. But the reason why I'm not doing that is because I want to emphasize this 1 to 2 here. And that would, if we do the association class, that doesn't come out clearly, okay? All right. So, any other information that we know associated with employees?
I mean, remove the condition between branch, associated between branch and account, just leave between branch and client.
No, we need. I think we want to say. I think an account is pretty fundamentally associated with an account is pretty fundamentally associated with a branch. That is a very strong association. He's suggesting client, just associate the client with the branch. But the problem with that is that a client can be associated with many branches. Okay, whereas an account is uniquely tied to a given branch. Okay, so I can open bank accounts in many different branches, and if I did that, if I took this out, I wouldn't know which account was in which branch. So I definitely need to have this association here. Yeah?
In between branch and employee, you can put manager.
Okay, we can have a manager association there. And you're saying branch to employee. Okay, so we have a bunch of employees that work for the branch, and one of these is going to be the manager. Okay?
But it says employees work for managers.
It says employees work for a manager. Okay, so another way I could do that would be this. Okay? I could have a relationship that says works for another employee. Okay? An employee works for one manager, and a manager has several employees that work for her or him. Okay? So I could do it either way. I could designate the manager of the branch, and all the other employees that work at that branch have that manager, the same boss, or I could do it as a reflexive association. Two possibilities there. They're both valid. Neither of them is wrong. However, there might be, as we finish off the diagram, we might discover other things. Question, point, yeah.
What about in between one sentence, the association class between branch and employee, the manager?
The manager, you mean here? The manager belongs here. Well, not really. To start with, this isn't a many-to-many association, and generally speaking, association classes go on many-to-many associations. Secondly, it doesn't quite fit the pattern. Yeah, but the manager's got to be an employee as well, right? So the manager is an employee anyway, and so this would end up being ... like that. I don't think that works so well. So we're going to choose between one of those two things. But there are a few other things that we could fiddle with. One of the things we haven't done yet is subdivisions. Okay? Divisions. How are we going to put divisions into here? Once you've got divisions, it'll help clean the diagram up a bit. Where are divisions going to go? Hands up. I hear people talking. Hands up. Somebody around here was saying something. Yeah, what do you think? Does it say that in the problem statement? Branch has many divisions? It doesn't say that. It says a bank has many divisions. Okay? If we go back and look at the problem statement, it says, a bank is divided into divisions and subdivisions such as planning, investments, and consumer. Okay? And the branches are considered subdivisions of the consumer division. So a branch is considered a subdivision. A branch is a kind of division. Okay? So how am I going to, any suggestions on how I'm going to model this? Yeah, in the back.
Division has many branches, possibly. Bank has many divisions.
Okay, got division. Division as a class. Is that what you're suggesting?
Yeah.
And it has many branches. Something like that? No. You're shaking your head there. What do you think?
I'm just thinking.
Sorry, the
consumer division alone has branches.
Says the consumer division alone has the branches, so we have consumer division as a class. I didn't hear who said that last comment there. Should the okay, I'm going to take some hands in the back.
Okay, there should be bank with subclasses, planning, investments, or consumer would be.
Okay, you said bank should have subclasses?
Yeah.
Okay, so consumer is a bank? No. On the right track though, yeah.
Branch is a subclass of division.
Bank is branch is a subclass of division. Ah, now we're getting somewhere. Okay. Okay, I like to put it on top, but for simplicity we'll just do that. As long as the arrow is pointing up, from my perspective, I like that. So branch is a kind of division. Okay. And what else do we know? Yeah.
How about if we have a subclass for division and one of those subclasses consumer and consumer?
Okay, he's suggesting other subclasses of division, including consumer division, whatever.
And then consumer has many branches.
Okay, how many people think that's a good solution? What's wrong with... You think that's a good solution?
Well, I don't think it's right to say that a branch is a division because...
Okay. You don't think it is. But on his point was that we should have... It says here that there is going to be a planning division, an investments division, a consumer division. Are we going to have three? He suggests three subclasses for that. Hands up who thinks that's a valid answer. Hands up who think it's not a valid answer. Why not? Doesn't sound too. You don't sound too positive about it. Okay. Because I don't sound positive, it's a wrong answer. I'm leading you on here, okay. There's a real reason, there's a simple reason why. Yeah, can you have the reason?
No.
I want a hand up who has the reason, yes.
There's no real difference between them, it could be a type attribute.
It could be a type attribute, there's no real difference between them, and we can add new ones. The bank is organized right now into 3 divisions, but it could always add other divisions, it could restructure itself. We don't want to have to program our system every time we restructure our organization. We just want a class that represents some kind of organizational unit. And let the attributes that have the values, we can easily change the values in the data to restructure. That can be done by a clerk at any point in time. We don't want to program stuff into our system that rigidly enforces some kind of organizational structure. I'm going to change this thing called division here. I'm going to change it to organizational unit. Okay? And I'm going to consider the branch definitely a kind of organizational unit. And I'm going to also say that I think that these organizational units can be broken up into various kinds of ways, in quite flexible ways. So I can say that, for example, an organizational unit may or may not have some unit that it is a subdivision of, and an organizational unit may have a number of subdivisions. There may be a number of subdivisions of any organizational unit, and some of these organizational units happen to be branches. That is a much more flexible approach to things, I think, than the other approach. And I'm also going to say, by the way, that these associations right now that are leading into branch, an employee is a manager of a branch, well, an employee could be a manager of any old organizational unit. And by the way, an employee could work for any old organizational unit. And by the way, having noticed on this thing here, this association has a label. I'm going to put works for here, going this way, to make it absolutely clear that we're talking what the difference is between these two associations. And I'm going to take this one off. That's not to say this is the only answer, but that this is a pretty reasonable approach to the problem. Okay? So I think it's tidied up that part of the problem quite well. Is there any other information that we haven't yet put into this problem statement that is there? Let's go back and take stock. We've got branches, we've got employees, we've got divisions, we call them organizational units, we've got credit cards. We don't have bank as a single unit. We do have managers, we dealt with joint accounts. We don't have address as a separate unit. In fact, there's something missing about address in the model. You'd have to read through the problem statement. In fact, I urge you, once you've done your diagram, go back to the diagram, read through the problem statement now in detail. Okay? And see if there's anything missing. One of the things we'll see is missing is it says that each branch has an address. Another thing I'm going to suggest is an alternative approach to dealing with accounts. If we go and look at the problem statement, we see that in the middle of it, there's this thing that says, there are many types of accounts. Okay, each has an expiry date. It's possible to have a joint account. Okay. Each type of account has a particular interest rate, monthly fee, and set of privileges. Okay? Such as ability to write checks, insurance for purchases, etc. Okay? So these privileges, we don't have any real notion of this, where to put the privileges is in here. So what I'm going to suggest is that we have a thing here called account type, which is going to allow us to put special types of accounts on the market that have particular kinds of names. So, for example, I go to OO Bank and they offer an Ultra Saver account. It's a kind of checking account, but it's a special flexi rate mortgage account, or a Visa account that earns you air miles. And all of these things can be account types that have a name and have associated with them maybe a description of the privileges, a number of things like that. Maybe whether checks are allowed. Actually, you're allowed to write checks on some credit card accounts, not just checking accounts. Interestingly enough, is there insurance available? You know, maybe there's insurance available in some of these accounts, and so some of these things this information that right now we've got in account in each instance really belongs in a group of accounts that are sold and marketed under a certain name. In fact, the interest rate, I would put that there as well, and the monthly fee. Generally speaking, you're not going to store that information in each individual account. That is, the bank sets the interest rate for all of its accounts of a certain type to be the same, and they would all be charged the same rate. So I'm going to put interest rate and monthly fee in there as well. And I'm going to just erase this line here to make this clear as daylight. An account type has many accounts. An account is of one type. It's interesting, we've got subclasses and we've got this type information as well. That's a perfectly valid structure. Somewhat uncommon, but perfectly valid. As long as this information can be applied, generally speaking, to most of these different types of things. Subclasses.
These are not necessarily monthly, could be per transaction.
Fine. Okay, so then we might have periodic fee and period. He's saying that it's not necessarily monthly. Okay, good point. Okay, I'm going to leave the problem statement at that point. Okay, I think that we've covered enough. I want to just go on to some of the lecture material briefly. But that's basically the strategy that you use when you are when you're solving one of these problems. Okay. Questions? Any questions before we go on? Yeah.
I was just asking if an employee can be a client at the same time.
Ah, excellent idea. Yeah. So we can. How will we do that? Make a superclass. A superclass on the top that is person, has a name. In fact, I have that in the answer. I just didn't get around to putting that down. Excellent point. So employee and client of a superclass person. Any other questions or comments? No? Okay, let's find out where we were in this problem. Okay, we were round about here. Oops. On slide 39, we said, here's a sequence of activities. So this is what we did today. Identified a first list of candidate classes, added associations and attributes, found generalizations. We didn't get round to the responsibilities and operations. We're going to get to that next lecture, okay? But first I want to go and review some of the stuff that we did today. Identifying classes, okay? What we did today was we were working on a domain model. So we did what we call discovering classes. We looked at our requirements, we looked at the data, the things in the real world, we discovered classes that exist in the real world. There's another thing that you do when you move on to the detailed part of the system, the user interface, and oops, just wanted to set this thing, the light off here for the camera. Once you work on the architecture of the system, you're going to have classes that represent things like clients, servers, messages, windows, pull-down lists. Okay, those things are not domain classes. They're classes that you invent. Okay, that you're inventing those as part of the design process. So some classes are discovered, they're the domain ones. Other classes are invented. Another thing we want to do when we're doing these models is to think, can we reuse anything? Is there a framework? If there was already an existing framework for bank accounts, we would try and use that instead of inventing our own. We also want to try and think of extensions. Okay, other things that we want to allow for possible future extensions, like new kinds of accounts, like debit cards, for example. We didn't put debit cards in here. Okay, an ATM cards. We didn't put that in this system. The question is did our model allow for that? We would have to review the model, and even if we weren't putting debit cards into this subsystem, we would have to make sure that it would easily be addable later on, so we wouldn't have to change our model to do it later on. Okay, we also want to see if we can learn from the work other people have done, similar systems. Okay, in order to discover the classes, what we did was we took a simple statement of requirements, we looked for the nouns and noun phrases. Okay, so noun phrases are situations where you have a noun that's more than one word. Okay, so like bank account is a noun phrase. Okay, and there are noun phrases that are more sophisticated than that. And we got rid of nouns that were redundant. Okay, so some of these nouns like client and customer are redundant. They mean the same thing. We got rid of nouns that represent instances, okay, like my different divisions, planning division, investment division, consumer division. They're actually instances, okay. We also said that we want flexibility, but there's two reasons for getting rid of those things. Vague and highly general. We didn't put classes in like system and service. Those are nouns, but they're too general. Or not needed in the application. Several times somebody's made a suggestion. I said, in this application, as this problem is scoped out, we're not going to add certain things because that's beyond the current scope. Okay? One of the things we didn't have to deal with here is whether we actually represent or not represent the users of this. Somebody had suggested bank teller. I would have said, well, that is a user of this system. Are we storing data about bank tellers here? The answer is we're not. So even though they're using it and they're doing operations on this, we're not going to actually store data. That's a typical mistake, is to always put all of the users into our models. Now, the clients are users. They are here. But the fact that they're users is independent of whether we're storing data about them. What you want in your model is classes that you're going to be storing data about, manipulating data about, etc. Okay? We started with classes that we thought were central and important. The class or classes that this system is about. This is only a hint. It only helps you with the process. It doesn't mean that you can't start anywhere. I just find that students get the right answers, and I get the right answer faster, and it's easier to work the problem if you start with a central class. Okay? And then I think about the clear and obvious data, the clear attributes and associations that we really need, and work out towards the classes that are more peripheral. Okay? And avoid adding too many associations and attributes to a class. If you find a class is getting a large number of associations, like we saw in account, that means, you have to think, is there some possibility that this should be split into several classes? And we split out the account type from the account, because we did discover that some of those attributes were not data that was supposed to be stored in each instance of account, but actually was data associated with several similar accounts that are grouped under a certain brand name or certain type. On slide 43, there's a number of types of associations that we typically find in models. So possesses, the has-a relationship is a very common one. Controls is quite common as well. Is connected to, is related to in general. Is part of, that's the aggregation relationship. We didn't actually have any aggregations that stuck out here in this model, but they quite often are. Has as parts is the inverse of that. Is member of or has as members is also another kind of association. Inverse, you can read it either way. Is a member or has as members. Okay, is a member of or has as members. Remember, when you're doing associations, every time you write an association down, immediately do the multiplicity of it. Otherwise, you tend to forget and you leave it as one-to-one. Okay, and read it in both directions. That's the habit you've got to be in. Read it always in both directions. Anytime you make a change to it, read it again. See if there's anything invalid. And if you're unsure, state an assumption as to why you chose a certain option. And label it clearly. You know, has-a being the default, but if there's any other possible association, especially if you've got two associations between the same two classes, you've got to label them then, because otherwise the meaning is unclear. Any questions? Okay, on slide 44 shows a very common mistake that people make. okay, between library patron and collection item in a library, some people would read requirements that would say, a patron borrows books from the library and does something and then returns books to the library. And they would, the naive modeler would put in borrow and return as associations. In actual fact, these are actions. These are going to end up being operations and methods, right? The real model is what is shown on the left, on the right-hand side here, where we have an association class loan. The actions are things that are done to create a loan, to delete a loan, or to change the return date of the loan. Okay? So don't, whenever you see verbs that are actions, okay, doing verbs that do things, then think that's probably going to be operations. When you see verbs that represent state, okay, then think maybe that's in fact things that are associations. So if we look at our list of associations, being related to is not an action verb. It is a state verb. Being a part of is a state. Being connected to is a state. Okay. To connect, you know, if we talk about an action of X makes a connection to Y, then that becomes an action. But being connected is more of a state. So think carefully what is state, what is action. And don't make this big mistake, big marks lost if you do this, of labeling associations with actions or operations. So go check your assignments as far as you've gotten, make modifications if you've done that. With attributes, you're going to look for information that's simply maintained in each class. Again, simple strings. A lot of the things which are nouns that don't become classes end up being attributes. Okay, so things like address and name and description, they're simple strings. Things like account number are simple numbers. Okay, they're also nouns, but they end up being attributes instead of classes per se. And over here on slide 46, we see another interesting thing to watch out for. Okay? In class person, on the far left, I've got name and address is. First mistake, don't make attributes plural. Attributes are always singular. Okay, so if you see this, you know you've got to make a change. If you see addresses in the plural as an attribute, there's more than one, you've got to do something about that. That's not right. If you need to store more than one address, it's got to be a separate class, as shown on the far right. Okay, so person has several, multiple. There's the asterisk addresses. Okay, and then each address has a street, municipality, province or state, country, etc. If there was just one address, it would be okay to put it as a single string. But if there's more than one, you've got to have a separate class. Another big mistake is what's shown in the middle, where I have numbered things. Municipality 1, province or state 1, country 1, postal code 1, then street 2, municipality 2. Okay, that is just faking the thing out. It's inflexible, because what if you wanted the third one? You know, you've got your business address, your home address, and your delivery address, which is somewhere else. Okay? Well, then you're going to have to add a third one, add more attributes. Each one requires programming. Far more flexible to just add a separate class. And in this case, I could have type of address. The type attribute could be the home, business, delivery, vacation, etc. Question?
In the case that you intend to use an array as the attribute, would you still break it out like that?
Don't use arrays as attributes. Okay? Generally speaking, that leads to inflexibility. And I would, in the modeling stage, I would leave that out. In the implementation, occasionally with fixed upper bounds, you can do that. But as a general rule, we're gonna model them as separate classes. It's much more flexible. Only with very detailed mathematical type classes, matrix multiplication, things like that, are you going to actually use arrays as inside classes. Okay. Slide 47 is the beginning of a whole problem, which we'll get into in more depth the next day. I'll work through one more problem for you. It's the airline system. I urge you to look at this problem too in advance of the class the next day, and try and work out how we arrived at all these associations, and see if there's any alternatives to them. Okay? We're going to pick up on slide 47 next day.